Okay, it's my third video I made today. The question is from the weekly contest. So you can see here you are given integer array A of size 4, another integer array B of size at least 4. You need to choose 4 in this. I I0, I1, I2, I3, blah blah blah. You can go through this the description, and then here we need to return the maximum score you can achieve. Actually, if you see the maximum score or minimum score is possible, we can use the dynamic array, the dynamic programming to solving this question. Actually, in this question, yeah, we have to use the dynamic programming solution here. So now I already create the solution. I'll just pin the first example in my node. So here we can use the recursion tree. You can understand we have a tree. We have two options: take or skip. You can take this one or skip this one. If we take this one or skip this one, and here's skip skinner 2. You can understand is I plus 1, and then we had 2 pointer, right? We point to the first index in B array, and we also have second pointer point to the A array. So now if we chose the first choice, we take 2, which means we also need to take the number from the A. So now we point to here, right? Okay, we take this one, and the second choice here is okay. I don't want to take 2. I want to skip it. Okay, you can maybe I use the just nothing. I didn't put here, which means we just skip it. So like skip, right? You can understand that S represent skipping, right? Now next step here also for here we also have two options. The first option is we take the 6 as our number, and then if we take it, which means we need to take the second number from A is 2, right? And here we don't want we don't want to take a number. I don't want to take the 6 a negative 6 right here, right? So and currently just 6, right? Because the period sound is 6, and then we don't need to do anything. He actually just I just put S here, right? Skip the negative 6, right? And then we keep going down. Okay, same thing here. We have two options. We take it or skip it. 4, right? If we take 4, which means we need to take 5. If the number from the both array, right? Need to point to here, and we need to take the 4 and the 5. Now let me remove this one. And then the second choice, right? Well, I don't want to take the 3. As we put S here, just keep going down. And then we pick odd number is 6. It should be negative 5. Negative 5 times to the 6, right? Is first option. And then second option, I don't want to take it. Now you just keep going down. You just understand the logic behind the recursion tree. Now here, we go back to this level. Now here, we first time we skip it, right? We don't want to take 2. We don't want to take 2. Now 6 4 negative 6, right? So which means in this time I want to take it. Okay, if I take it, so now we need time to the this one from 3, because the previous we didn't take any number from A, so which means we cannot take any number from we first time we didn't take any number from B, so in the meantime we cannot take any number from A, right? So that's why here we can use the 3. The same thing here. Okay, I don't want to take negative 6, right? From here, so I put the S here. You just use this way to keep going down for all the possible pair. And then here we also use the memorization right here, right? Because we need cache. So sometimes we have the repeated process. So we don't want to repeating the process again and again. It's wasting our time, right? So we use the extra memory, and the time capacity also will be increased. So we don't want this to happen. So here we have used the cache, right, to store the process we already did. So like with the unit way. So now start implement this one. So first step we need to get n of n is the length of b. We need to be the length, and then for let's say we need to create an array, dp array. It should end with the 4. So why here is 4? The a is 4, right? A always only 4 number. So here we just provide the 4 here. Next step we need to fill out with the maximum number for each in the dp array. We can p, and then here we need to provide arrays field, and then we need p with the row the minimum value. Next step we need to create the index so we can go through the last number. Is my solution is the bottom up dynamic array, dynamic programming. So I will start from here. You also can read. You can start from left to right or right to left. Is up to you, right? So now here is 3. We need to provide 3, A, B, and DP. Now here provide J and there A. Now here we need to check if J less than I 0, we should return. Sorry, it should be okay. Now if I less than 0, so we need to return the row minimum value divided by 2. So why we need to prevent the edge case, prevent the number out of range. So that's why we need to divide by 2. And now next step we need to check the DPI not equal to 0. Oh, sorry, not 0. I like 0, and here we just return the. Yeah, we don't want to repeat the process, right? It's wasting our time, so we don't want that happen. So that's what we need to check here. Now here next step, DPI with J, and then we need to check which one which if we take it or we skip it, which one we get the maximum number. So here we need to provide the maximum method here. So here DFS. The first function is for skipping. Okay, now skipping I minus 1 J. We don't need to, we just key the J pointer to next, and then A and a B and the DP. Now the second function is we take the both number from the birth array, right? J minus 1 and then A, B, and the DP, and the plus, and then we also provide row A with J times to B with I. Now we need to return I with J. Now you can see here on this run it. You guys pass on the test case, Now let me analyze the time complexity. So you can see it's n squared, right? But the space, because we just go through the array only once, right? So that's why time complexity is b of n here. Yeah, thank you for watching this video. And here space it can be understand is space complexity is n times to 4, right? But 4, we know following the algorithm rule, we need to take out, we can get rid of 4 from the space complexity, right? So now finally just only n left. So n is the space complexity. So thank you for watching this video.